In this video, we are going to create a loop tap game in Flutter. The basic idea of this game is you tap the button and you tap again when the ball is inside the colored segment. You score a single point when the ball is inside this segment, and if you tap outside of the segment, the game will be over and you will see your best score. Since we are going to code in Flutter, we also have to take care about different platforms. So this game is also responsive by default, and it will also work with the touch input. And if we are out, we are out. So in this part of the video, we are going to create the loop. And so the loops feature is we will provide it an angle of the start angle, which is this one, and the end angle, that is the point in the end of the segment. And if we write 360, it will be a complete loop. And if we write 270, that is here right now, it will start from 0 and it will end to the third quadrant of this circle, that is 270th degree. So let's get started. So we are in the editor, and this time we are going to create the loop. So what we have to do first is we will create a folder name like painter. We will create a loop here. Let's name it loop painter dot. And what we actually are gonna do here is create a custom painter. So we will create a class name loop painter, and which will extend from the custom painter. Make sure it is custom painter, not the custom paint, and we will just import the material library here. Now we want to define some of the problem. Let's think about it. So basically we want the stroke width of the loop, that is how much thicker the loop will be. So it will be a double, and we will name it stroke width, just stroke will be good. Now in the second, we want from what point the loop segment should start. From 360 degree of the circle circumference, we can take any point, so just name it start angle. And the next one will be how much would be the length of this loop, so we can just make it end angle or just make it angle. Now we want color should be the color of the loop. That's it. Now we have to create the constructor for this, so let's just generate constructor and we will move down. What we have to do is we have to override two methods here. So the first one is the paint one, what we are going to paint on the screen, and the second one is should repaint. This should repaint will repaint its paint, whichever it is it's painting, if it returns true. So what we have to return is we want to repaint this if anything from our property changes. Like we have the old delegate, so it won't be custom painter, it will be this. Now we want if the angle is not equal to the current angle, or delegate dot start angle is not equals to current start angle, or the color, the old delegate, the old widget's color is not equals current color, or finally if old delegate dot stroke, that is the width of the loop, is not equal to the current stroke, we are going to return it. So let's save this, and we are going to go to paint our widget here. So before we do anything, let's just use this here. We are going to remove this part from here, and we will use a custom paint, and for the painter we will pass the loop painter here, and we will let's just fill it with some random values like 20 for the stroke width, and for the starting angle let's just make it 0 for now, and for the end angle that will be let's just make it 180. We are going to use degree here, but the paint method or the canvas are expected to use radians. So we will also create a utility for converting our radian to degree, or the degrees to radian actually. So let's just make it a little bit brighter like amber here, and save it, and we have to remove the constant from here. Now let's just move to paint. Before that, we will need a utility that we can have converter, that is a degree to radian converter. So we will name it a converter dot, and we will name it what it will return. It will return a double. So what it will do, it will take value as degree like whatever is the value in the degree, and it will return us this value, that is pi by 180 multiplied by angle. So we have to import pi from the math library here, and since math library is pretty big, we don't want to get everything, we just want the pi. So we will do this. Now we will move to loop painter here, and what we have to do is start the painting. Now first of all, we want to get the center of whichever is the size of the widget, we want to get the center of it, and we will save it as size.center.offset.0. So what this will give us, if we have a size box of like 100 by 100, it will give us a center of like 50 by 50. The offset here is deciding the shift of the origin. Since we are not shifting any origin, we are giving it an offset of 0, so that the center of this widget will be exactly the half of the size. Now the next step will be to create the path. Now to create the path, we will create a path and we will use a cascading operator to move forward. Now we want an arc. Actually, the loop segment is basically an arc. So what we want here is a rectangle that will be from center. It wants a center, and then we give it a width and a height so that it has a bound. So what will be the width and height? I guess since we have a size here, we will give it a width here and a size of height here again. And we move here. The start angle is start angle, but to be sure, the arc method takes everything in radians. Since our start angle is in degrees, what we will do is use our converter degree to radians to convert our degrees to radian values. Now the sweep angle is how much will be the length of the segment from its start angle. So since this is also an angle, we will just use degree to radians and we will pass our angle here. Now since this one is force move to, we are going to make it true, because if you hover over it, you will see if the argument is true, start a new subpath consisting of an arc segment. It won't close the segment, so that it won't be a segment of the circle, but it will be a segment of an loop, that is circumference. You will see what I mean by that is if we have path. Now we have the path, but we don't have any kind of what we say the paint. The paint decides in a canvas what will be the color or what kind of stroke will it be. So we will initialize with paint, cascade it again, give it a color, and we will just use color here. Then we will make a stroke cape, and what this will do is painting style, not that one. I want a stroke cape, so it will be stroke cape dot rounded, because we want a rounded edge of our stroke. It won't be a flat. The next one will be stroke width, that is how much width will be the loop having. So we will name it stroke, that we have the variable for that, and then we will use a style. So the paint will decide whether this is a fillable object or it's just an outline of that object. Since this is just a border, because we don't want to fill the inside of the loop, we are going to use a painting style dot stroke, so that we can only have the border of the paint. Now since we have the path ready and since we also have the paint ready, we want to paint this on the canvas. We have the canvas passed us in the paint method, so we are going to use it. We will use it canvas dot paint path, not this one, this is the path, and we will pass the paint and the path here. And if we save it, you will see nothing actually happened. What is the issue here? So let's go to the main and see what is the issue. Now if you see it in the whole here, you won't see any size for the custom painter. That's why it has an infinite size. We can give it a size here, like I can give it a size of square and make it 300, and it will get us a loop. Now if you see it clearly, the 0th is this point in the loop. 0 is a 0 angle, and we will go around by 180 degree here, and this is our angle, the end angle. So the start angle is this, the starting point for the loop segment, and the angle, it is this, is the ending point for the loop angle. We can check it whether it is working or not by changing the value. and if we enter 270, it should cover the 3/4 of the quadrant. So basically we have a loop now. Congratulations, we have completed the first part of the video. In the next part, we are going to create the ball, and we are also going to create a ball so that if we give it a angle, it will be at that point. So basically the loop logic won't be working there, but you can actually code the ball with loop. But let's see how we are going to code it. So let's see you in the next video. Bye bye.